Good morning, grade fives. Lovely to have you with me again. I'm sorry if I look a little bit sleepy and I have some bags under my eyes. This here is Emmy, and she's the reason why I'm not sleeping all the way through the night. She's not sleeping through the night, and so neither am I. Anyway, let me put her back on the floor so she can play with her toys and have a rest. She's a little bit restless. Okay. Before we get on to the maths of today, let's have a look at just a birthday message from the teachers of grade 5. To all grade 5s out there who've had your birthday during lockdown, I hope that despite being at home, it was a good one. I'm sure you'll get a chance to celebrate with friends afterwards. I hope that this year is the best you've had so far, but that every year keeps getting better.
Hi grade 5s, it's me Miss Kun, just wanting to wish all of you a very happy birthday. If it is your birthday today, have the most incredible day. I hope that it's special, I hope it's magical, and that you do something fun and exciting and something just to make you smile. Just know that I'm thinking about you, and I wish you a wonderful year ahead. I hope it's going to be a great one. I know it's going to be a great one. And I will see you in our English classes. Lots of love from me. Hakuna Matata. Bye.
Hi, grade 5s. Just a big happy birthday to you if it has been your birthday during lockdown or you're still waiting for your birthday to come. I know that it must suck not being able to see your friends, but I hope you were spoiled in some way. And remember, lockdown won't last forever, and as soon as it's done, you can get out there and celebrate. Have a great one.
Okay. And now let's jump across to our maths for today. So as per usual, just a reminder, if you have any questions, grade5@worksheetcloud.com. If you come across an answer in a worksheet and you're like, no, I'm sure I did this right and this is not the same as I got, let me know. It is possible I made a mistake in the memo. It has happened before, so you can always just check in with me using that email address. And then after the lesson, click on the link above, do the worksheet, and you can check that you've mastered what it is that we're doing today. So as per usual, the next slide will be 10 mental arithmetic questions. You will have 40 seconds. That's the time for you to check or to do the answers. Your 40 seconds start now. Stop that. Naughty. Lie down. Punch her. Halfway there. Time is up. Sorry, I disappeared for a moment. The dog was busy, the puppy was just busy destroying the carpet and I needed to move her out the way. Okay, let's go through the answers. 18 minus 12 is 6. 12 minus 5 is 15. 11 minus 3 is 8. 18 minus 1 is 17. 17 minus 9 is 8. 18 minus 4 is 14. 8 minus 3 is 5. 20 minus 4 is 16. 15 minus 2 is 13. And 14 minus 5 is 9. If you missed any of those, just rewind a little bit and go through and you can check your answers. Okay, so today we're going to have a look at patterns. Patterns are all around us. They are in nature, they are in real life, and if you have a mathematical brain or a brain that likes numbers, you might find patterns wherever you look. I'm always looking for patterns, whether it's a pattern in number plates that I see, whether it's a pattern in the number of steps it takes me to do something, or anything like that. So maybe you are somebody who finds patterns in the world as well. So our goals today, to be able to recognize and extend simple patterns, often number patterns that you come across in class, at school. When we look at patterns, we're trying to make sense and we're trying to figure out the rules so that we can extend our patterns and find out missing numbers or missing shapes or missing colors. So it's our way of making sense of the world. Even the puppy is starting to learn patterns. So when she accidentally wheezes on the carpet inside and I shout and say no, and I take her outside, she realizes or recognizes the pattern that making her wee on the floor gets the shouting and gets her taken outside. And that's how she learns from that. So we're always learning from patterns. I'm sure that you know the sorts of things that you shouldn't do to make your parents cross. That's also learning patterns in a way. But we're going to focus on number patterns today. Before we get to number patterns, I just wanted to glance at a couple of these things here. So that shell up there forms a pattern. And in fact, if you do the measurements of that shell, there's a mathematical pattern to it as well. The flower, I think it's a sunflower, could be a daisy in the middle. You can definitely see the patterns here as the spirals go out one way and the other way. And then there's a third one that's out in between. In fact, if you were to sit there with a magnifying glass and count them, and the same with this, these follow a particular sequence, which is very exciting. It's called Fibonacci's sequence. Look at me, such a nerd, getting excited about maths. There is, in fact, a YouTuber called Vi Hart who does maths videos, and she has thousands, hundreds of thousands of followers, and she's just doing maths videos about maths, not teaching you how to do maths, but maths in the sort of various things. So that's pretty cool if you want to check out Vi Hart on YouTube. So before we move on to looking at our whiteboard and what we're going to look at, some patterns, examples of patterns, just wanted to look at this word called a term. A term is what we call each of the, I suppose, things in a pattern. So if it's a pattern made of shapes, then each of the shapes is a term. The first one would be, the first shape would be term 1, the second shape would be term 2, the third shape would be term 3, and so on and so forth. If we're doing numbers, the first number was term 1, the second term 2, and so on. So the first thing I want to just look at is this sort of two broad categories of patterns. The first of all, it's the repeating pattern, and that's where you've got something that happens, a sort of sequence of things that happens once, and then the same sequence again, and the same sequence again, and the same sequence again. It's the simplest kind of pattern, and often we miss it because we're looking for something more complicated than that. So keep an eye out for those. We'll look at some of those first. Secondly, we've got changing patterns. In grade 5, most of these are simple, and you'll find that the change between each term is the same, but sometimes the changes are different, and we will look at a few of those ones towards the end of the lesson. So my first piece of advice is to look at the gaps. And when I talk about the gaps, it's often the space between two numbers that we're talking about. So if I've got 3 terms, I look at the space between them, and often there's an easier to see pattern in the space, and that's where we can work out what the rule is and find out the missing numbers. And my second piece of advice is if the terms, the numbers, are getting bigger, then it's probably going to be a plus or a times thing that you're looking at, so keep an eye out for those. And if they're getting smaller, look out for minus or divide. You won't get many divides while you're in school because they tend to get quite small quite quickly and end up being fractions. So most likely it's going to be a minus 1. So of course the operations plus and times make things bigger, and so if the pattern's getting bigger, it's probably one of those. And if the pattern's getting smaller, minus and divide are the ones that make things smaller. Okay, let's go across to our whiteboard. I have got a couple of things here. This first thing is from Kids Maths Dictionary. It's a really, really cool website if you want to check out the sort of terms for everything. So thank you to them for this great image, and you can always check it out if you need to. Okay, so let's look at the first pattern. Let me just get my iPad open here so I can write. So looking at that first pattern, we have shapes. We have a triangle and then a square and then a pentagon. So we have a triangle and then a square and then a pentagon. And then we can see that same set of things repeats again. Triangle, square, pentagon, triangle, square, pentagon. And so if you had to continue with this pattern, you'd realize you would have to do triangle, square, pentagon, triangle, square, pentagon, triangle, square, pentagon, and so on. However, do take note that if you had something like this, so triangle, square, pentagon, I know that's such a beautiful pentagon I've drawn over there. If you had there, triangle, square, pentagon, and that was all, and it asks you to say what the next one is, you could easily say, well, this one has 3 sides, this one has 4 sides, this one has 5 sides, the next one will have to have 6 sides, and if you drew that, it would be a hexagon. All right, so you could quite legitimately do that. So if you only had the 3 and then that, you could definitely get that right by doing that, or doing a repeating sequence. All right, looking at the second one, we've incorporated some colors for this one. So again, we've got the same 3, they're just in different colors, and those colors are also repeating, they are part of the pattern. In the color wheel and rotation one, all I need you to do is take a look at one of the colors. So I'm going to look at green. So green is in the top left, then it's in the top right. So it's like the ball has rolled, or the wheel has rolled. Bottom right, bottom left, and then back to the top right. So this one and this one are actually the same. And this will repeat over and over again because it's the same 4, just repeated once after the other. Having a look at the one underneath, this one is a bit of a different pattern because you'll notice that this one and this one are both actually the same. So it's a quartered circle, and the orange 1 is up in the corner. Then it's a quartered circle that's flipped with the orange down in the bottom corner. So these 2 are the same. And then we go back to what it was in the first. So it's sort of like a pattern. If I did a number pattern, it would be like 3, 3, 4, 4, 3, 3, 4, 4. So that's the pattern, following like that. 2 of the same, then 2 different, then 2 of the same and 2 different. Also a very legitimate pattern, nothing wrong with that. Popping down to the next one, this is where we're looking at numbers, and it has a name called arithmetic. Don't worry too much about the name. You're unlikely to have to say whether something is an arithmetic or geometric progression or sequence. But there it is, you have it if you want. So you can see these, we've got 2, 4, 6, 8, 10, 12. We put commas in between them. That's the best way to do it. You might find some of your teachers do a semicolon like this, also fine. I would say stick to commas unless your teacher does semicolons and has asked you to do semicolons. So when I said look at the gaps, what I was saying is look at that. So the gap between 2 and 4 is 2. The gap between 4 and 6 is 2. Each of these gaps ends up at being 2. And using that, I can see that the next number is going to be 14, and so on and so forth. I can use the rule, which is plus 2. So with each term, term 1 to term 2, we added 2. Term 2 to 3, we added 2. Term 3 to 4, we added 2. So just adding 2 each time. So we call that an arithmetic sequence. So that's using plus. It was getting bigger and it used plus. Another one of those ones that gets bigger is this one. You won't have too many of these at school because the numbers get bigger really quickly and it's quite tough to work them out. Not for your teacher, but for you. Unless your times tables are really good or your mental arithmetic. Okay, so if I look at the gap between these 2, I notice the gap is 2. I notice the gap is 4. I notice the gap is 8. So in fact, we're getting bigger, and the bigger is not always the same. So you see, in our previous one, it was always plus 2. In this one, the first one is plus 2, then it's plus 4. And because these are different, that's a good indication that it's going to be multiplication. Okay, so using that pattern, we can see that it's going to be times 2, times 2, times 2, times 2. And if we wanted to work out our next one, we're going to go times 2. Let's put it at the bottom, times 2. And if you're not quite sure about that, so 2 times 32. Quickly do that in your head. We'll break it up. 2 times 30 is 60. 2 times 2 is 4. So the answer is 64. You might also have noticed, just out of interest, that it's kind of like adding itself to itself, which is what times 2 is. Let's look at a couple more patterns quickly before we move on to some other examples. So having a look here at the yellow one, what I did in the first one to get from the first to the second was I added one there, and one there. And that's these three here. In the next one, I added this one, and this one. So I made each of the arms longer by one each time. So each time I'm going to add 3 blocks. So in fact, my rule is +3. But if I wanted to look at the numbers specifically, so the numbers that are written down here are the terms. So term 1, term 2, term 3, term 4. And what you can notice is this has 1 in it, this has 4 in it, this has 7 in it, this has 10 in it. And we'll come to that, one of those kind of patterns towards the end of the lesson. So if we wanted to look at it just in numbers and not in pictures, that would be how we would do it. Looking at the other example that we have over here, let's look at the first one. So what we did was from term 1 to term 2, they've called it picture, but it's terms. We added 1 on each corner. In other words, we added 4 plus 4. In the next one, we added 1 on each corner plus 4. So in fact, our rule is +4. So +4 again. So we started off with 5, then 9, then 13, then 17. So that's what that pattern is in numbers. 5, 9, 13, 17, rule being +4. You can probably see that over on the right-hand side, I've already written down some questions. I've deliberately done them in different colors because they're in kind of sets. So the first one is probably, no, not probably. The first one is the simplest possible series that you could get. All right, it's +1 every time. It's counting. So I'm sure you would have no difficulty figuring out that the next one's 5 and the next one's 6, and that the rule is +1. So each time from one term to the next, you add 1. Looking at the next one, you might recognize that is the 2 times table. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and so on. If you didn't recognize it, what you could do is look at the gap. So that's got bigger by 2, bigger by 2. And you can see that the rule is +2 each time. And so you can now use the rule to find what the next terms are. So adding 2 each time. Your teacher might be a little bit sneaky, not deliberately sneaky, but just, I suppose, to extend you. And they might not start at the beginning of the 2 times table. But number 3 is also the 2 times table. So 36, 38, 40, it's just further on in the 2 times table. Even if you didn't notice that, to get from 36 to 38, we added 2. We added 2. And so we can see that our rule for this one, let me just put the rule for the previous one as well. Our rule for this one is also +2. And so we can use that to find 42 and 44. And those are our missing numbers. Jumping over to the third one, your teacher might be even more good at extending you. I was going to say sneaky again, and then I realized you'll go back to school and tell your teacher that you watched this program where the teacher said your teacher was sneaky. No, that's not what I'm saying. They're really just extending you. So in this one, they've used odd numbers. So odd numbers are not in the 2 times table. But the pattern is still, or the rule is still +2, because each time we've added 2. And so we can say our rule is +2. And we can work out that that's 33 and that's 35, because we're adding 2 each time. And so, yeah, you can see that's why I put them in the same color, because they are the same rule. But just watch out, it won't always be nice and neatly in the times table of a specific times table. So that's not, those are all +2, but it's not, doesn't mean they're going to be in the 2 times table. It doesn't mean it's going to start with 2. Looking at number 5 and 6. So this is getting smaller. So in fact, we've gone -5 there. That's the gap. -5 again. And because we've seen it twice, we can now call it the rule, -5. And now we can use our rule to find the missing numbers. And if your mental arithmetic is good, you can just go down by 5. So again, the next one is the same rule. That's why they're in the same color. And the only reason I've chosen this example is it's again -5. It's just not numbers that are in the 5 times table. So each one of these is actually one less than the one above it. But let's not look at it like that. Let's look at it in terms of its maths. So the gap is -5. The gap is -5. And now we've got our rule. We can do -5 each time. And we can come to our answers that way. Number 7, all on its own. It's just another subtraction one. And this time, just take notice that often your teachers will cross over a big barrier like the thousands barrier or the hundreds barrier, that sort of thing, because it's one of those points where if we're not awake, we might get it wrong. So your teachers are just extending you, checking to see that you're managing. But if you look at the gaps, you can see that it's -3, -3. So we've now got our rule, it's -3. So 97 -3 is 94, -3 is 91, and so on, -3 each time. So I've got quite a few of this next sort in your homework today. The ones we've done up until now, I've given you the ones to look at the end. This time I've mixed in some, and you can't necessarily see where those ones are and where they're coming from. So we do have two numbers next to each other, the 6 and the 4. So I think that's really the best place to start instead of guessing. So I can see there is a gap of 2. So to get from here to here, I added 2. All right, but we're going to have to work backwards to find this one. So to go from here to here, we went -2. Let's see if that rule is going to hold for the next one. So -2 again is 8. I can't say for sure that that's correct, but let's see if it lines up or matches up with the 10 if we continue using the same rule. -2, 10, it does work. So let's keep going and see if it matches with the 14, and if it does, then we can know the rule for sure. So -2 again gives us 12. -2 again gives us 14. -2 again gives us, I've been going the wrong way. Let's quickly rewind that. Okay, in my brain I was doing the right thing. I was saying the wrong operation, so I'm going to go right back to the start. So to go from here to here was -2. 6 minus 4 is 2, not +2 is 6 minus 2 is 4, not +2. So going this way, we are in fact adding 2. And like I said, we're going to check whether it works each time. 8, yes, it worked. +2 got me to 10, +2 got me to 12, +2 got me to 14, and +2 got me to 16. So the rule did work. But when we're reading a rule, or when we're stating a rule, we state the rule when it's going from right to left, the way that we read. So our rule for this would be -2. So each step from one term to the next, we -2 because we do our work from left to right. That's how we read a sequence. Okay, I've changed completely. We're now moving over to one which is using multiplication. If you were paying attention, I think this one came up as one of the examples as well. I can see I've got gaps. I can see the gaps are not all the same. And what I'm going to have to do now is to look at what the gaps are. So they're the gaps 2, they're the gaps 4, they're the gaps 8. So my gap is changing. It's getting bigger and it's not the same, so it's likely to be times. And in this case, it's ×2. So ×2, ×2. And if you're paying attention, you won't even need to look it up. 32, 64 each time. Going ×2 and ×2. Let's look at the next one. Now this one is very confusing. Again, I'm going to start off, but I lie, it's not confusing. It's just one that you won't see straight up what it is. So let's look at the gaps again. So my gap here is 2. My gap here is 3. My gap here is 4. Hang on a second. I noticed something about those gaps. Any guesses what you think the next gap's going to be? If you guessed 5, you're correct. So 5 makes it 15. 6 makes it 21. There we go. And so the rule, this one you won't be likely to write down the rule. This is the kind where you just be able to complete it. The teachers are unlikely to ask you to write the rule down. There is a way to write the rule, but we're not going to write it now. It just looks really complicated. I think I'll just confuse everyone. Okay, so the rule, I forgot to write the rule for the previous one, which was times 2. So let's jump on to number 11 and then number 12. So these two I've picked because they're a little bit different. This is the kind your teachers might challenge you with. They're quite difficult, but once you start, particularly number 12, once you start looking at the gaps, it makes a lot more sense. So let's have a look. The gap here to get from 16 to 12 is minus 4. The gap to get from 12 to 14 is plus 2. Right now I look at that, I'm going like, I'm not seeing any pattern here. Nothing yet. I don't know how you could get minus and plus. I mean, that's not times, that's not minus, that's not plus. That's definitely something weird. But let's carry on looking at the gaps. So going from here to here was minus 4. Ooh. And going from here to here was plus 2. I'm sure you've seen the pattern now. It's a pattern that involves 2 different steps, one after the other. So your teacher might give you one of these, but it would be one that's fairly obvious like this if you look at the examples. If you look at the gaps, you should be able to see it. So you can guess the next one will be minus 4, which makes it 8, and the next one will be plus 2, which makes it 10. And there you go, there's your pattern. Last one. Again, you wouldn't be required to write down the rule for one like this. So let's look at the last one. Again, I'm going to look at the gaps. So that gap is a gap of 3. That gap is a gap of 6. That gap is a gap of 12. That gap is a gap of 24. There is some kind of pattern in there. If you look at the numbers 3, 6, 12, 24, I'd have to look really closely because the gap is doubling each time. So then my next gap would be 48, which makes this 95. And the next gap would be 96, and so on. If you want to know the rule that I used to create this one, and again, I'm not showing you the full screen, the rule I used to create this one was times 2 plus 1. So 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10, plus 1 is 11. 2 times 11 is 22, plus 1 is 23. 2 times 23 plus 1 is 47. And 2 times 47 plus 1 is 95. So the difference between number 11 and number 12 is that here we had one step between the one term and a different step between the next term. Over here, we just have 2 steps between each term, and that's what makes number 12 quite a lot more complicated than number 11, and also, again, not one you're likely to come across unless your teacher is particularly good at extending you, which means then that you're particularly good at maths, because teachers don't extend children who they think are not good at maths. We actually don't try and trick you. We try and make you better at maths. And that comes to the end of what we've got covering in this lesson, looking at patterns. Just a reminder, if you have any questions, you can email me, grade5@worksheetcloud.com, and click on the link above, do the worksheet, and then you can check to see whether you've understood some patterns. If you've really struggled with them, don't stress. This is something that comes. The more you practice, the better you are, the more patterns you see in the world, the more your brain gets fascinated by patterns. Anyway, I hope that I've imparted some of my passion about patterns to you today. I'm going off to play with my puppy. Grade 5s, have a lovely afternoon. I look forward to seeing you again soon. Goodbye.